The goals are different, so we are serving the customer, we are building the product instead of research paper. So we start there where the academic research stops. Maybe the one major difference, what is very specific for quantum computing, is that geopolitics. I want to mention that one. So I'm citing here Ken McCallum, the general director of MI5. So he's not the boss of James Bond, if you know James Bond. That's MI6, and this is MI5, so it's for different purpose. So if you are operating at the cutting edge of tech in this decade, you may not be interested on geopolitics, but geopolitics is interested of you. And this is exactly what we are now experiencing in quantum computing. So there is a lot of geopolitics in place, there are a lot of export control, there are a lot of governmental fundings to the critical technologies. So the quantum computing is very special technology, it's not just another technology. And particularly, it's a disruptive technology in future. When the quantum computers are more capable, they can change the world. So the countries are interested in quantum computing particularly for the reasons of breaking encryption codes, sometimes after a long time, not in near future. But anyway, this is the core of national security, and that's why there is so much interest. And then there are other reasons. But about the mindset, so we have been hiring more than 100 quantum PhDs. They come from academia, and there are a lot of things that they have to learn. So that the change in the mindset is the big one. I already mentioned the customer focus, which is new for many. And the another one is the teamwork. In academia, each researcher is basically working on his or her own thesis project, but in a company it's a joint effort. And another one is about the quality. So it's not enough for us to build one hero device, but we have to build a product which is reliable, it's repeatable, it's everyday in top-notch condition. We are concentrating on uptime and the user experience, so it's easy to use, not only that it can be done, things can be done. So let's say that reaching like high fidelity, 3 nines of fidelity, it should be every day for every customer job. And then the final one is the scale. So we are taking quantum computing seriously. So it's going to be a big thing in future. And that means that we have to fundamentally change the way how we are building quantum computers. Not only making one of them, but many of them, and maintaining them and making them industrial products. So we have been delivering more than 6 systems which are used by the customer in HPC centers around the world. And it's not enough to have a PhDs researchers there, but we need many other professions in different fields. And one particular challenge for us is the cabling. So in a cryostat of 150 fully tunable transforms with tunable couplers, we have more than 2 kilometers of RF cable and tens of thousands of connectors. So that's a lot of work to fasten them all and have in a top-notch condition all the time. So we have to develop new solutions. For that, we need to have a good network of partners, technology partnerships needed with like-minded countries, with the best companies around the world, and good subcontractors, vendors, and a value chain has to be built so that we can make it. So no one will make it alone in future, but we have collaboration. We need standardization, and of course we need to involve end users and build end user forums where the customer experience is communicated. So those are my observations.
So now let's fly from Finland to France. So we could